Welcome to this ADACS webinar. My name is Leonie Chevalier, and in this video I'll be introducing you to the programming language Python. During this webinar, I will be covering a basic introduction to Python as well as how to set it up on your machine. We will progress through some of the language basics and the use of packages and functions. This webinar comes with a Jupyter notebook that contains the examples we will be going through as well as a few challenges to try your hand on later. So, let's get started. First of all, what is Python and why should you use it? Python is a simple and easy to use programming language. It can be fast, powerful, it plays well with others, which here means it can interact with other programming language if need be. It runs anywhere, it is easy and intuitive to learn even if you've never programmed before, and best of all, it is open source. Python comes with thousands of third-party packages that are freely available to use. It is always worth, when starting a new project, to browse those modules beforehand. It may save you a lot of time instead of coding things up from scratch. Among astronomers, Python is the most commonly used programming language. In 2015, 67% were using Python. I would speculate that these numbers have increased since. There is a large number of astronomy-related packages for you to use, such as AstroPy, which now includes nearly all of the functionality that was previously offered by IRAF, to those of you who are familiar with IRAF. Now, how to actually set it up on your machine. Lucky for you, if you use a Linux or OS operating system, Python will already be installed on your machine. However, your Python distribution may be in need of an update, so you're up to date to the newest version. For Windows users, please check the Python website for the downloader. You can also use package management systems such as Brew and apt-get. It's also worth checking out Anaconda, which comes pre-installed with a number of key packages such as SciPy, NumPy, and AstroPy, which you will definitely find useful. Having mentioned that your Python distribution may need an update, it is really important to know that Python 2 and Python 3 are indeed very different. If at all possible, you should solely be working on Python 3, as Python 2 is no longer receiving updates or support. Now that we are all set up, let's dive into some of the language basics. Let's talk about variables and data structures. Variables are going to make your life simpler. And in Python, unlike C++ or Java, variable types are assigned dynamically. That means no need to specify, as in our example here, where x is defined as equals 0, and we do not need to tell Python that x is an integer. Python knows that automatically, and the same goes for characters, floats, and strings. Want to add an integer and a float? Not a problem in Python. Just make sure that after the operation, you are still working with the type that you are intending to work with. Now, let's move on to data structures now that we know how to define a variable. For storing and processing more than a single point of data, Python comes with built-in data structures such as lists, dictionaries, and tuples. Lists are a collection that is ordered and changeable. It also allows duplicate members. Dictionaries is a collection that is unordered, but still changeable and indexed. It does no longer allow duplicate members. And finally, tuples. Tuples is a collection which is ordered and unchangeable. It does allow duplicate members, however. Now, what does this mean in terms of a physical example? Let's start with Python lists. You initialize a list by using the square brackets to surround your comma-separated values. Here we have a list of fruits that contains apple, orange, and pineapple. You can access individual items in the list by calling your list name, immediately followed by square brackets with an integer of the item that you want to access. Now, it's very important to note that indexing in Python starts at 0 and not at 1. You can modify your list by appending new items to the back of the list or adding them into specific positions that you can write You can also overwrite existing entries or remove them. Dictionaries. Dictionaries you create by using curly brackets. A dictionary consists of keys and values. You add a string as your key before separating it with a colon from the associated values. Here we have a dictionary of books. Its key values are title, author, and year. It has 2 entries for each of them. The book titles are Great Expectations and The Way of Kings. There's also their authors and years of publication in this dictionary. Now you can query your dictionary using its keys. In the example, book_dict in brackets title will return a list of book titles that are stored in this dictionary. This returned list you can in turn query like you'd normally query a list. Again, you can add, change, and remove data in this dictionary as you please. And finally, let's move on to tuples. Tuples are created using round brackets. As tuples are unchangeable, the example of trying to change our furniture tuple in position 1 from sofa to armchair will cause an error message to trigger, as we cannot edit a tuple after it has been created. Nevertheless, we can query our created tuple the same way we would query a list. Those were the basic ways to interact with data structures and variables. You can use that knowledge now to write your own functions. First of all, a function is a block of code that only runs when it is called. You can pass data and parameters into a function. The function will of course return a result that is specified by you. Inbuilt Python functions, which you may have come across, are the help function and the print function. As we said before, Python comes with an incredibly large number of third-party modules. To load any external functions and modules into your code, you use the import statements. Import statements are generally found at the very beginning of your code, so that all the dependencies are clearly visible to you or anyone else wanting to run the code. There are various ways you can use the import keyword depending on whether you want to set an alias, load specific functions, or load an entire library into your code. To set an alias, you state import. Here in the example, we're loading the package numpy, so import numpy as np, where np now is the alias. We can now access all of the function and modules from the numpy package using this alias. When loading only a specific function, here from matplotlib import pyplot, it will only load the one function that we have specified. We can specify multiple functions from a certain package. To load an entire library, in our example from astropy import star, the star stands for the entirety of this module. This can be computationally expensive, so stay away from this unless you really need to use it. You can of course write your own function or even your own modules. Python initializes a user-defined function with def, followed by the function name and input variables. We show an example of a simple addition function that adds 2 numbers. You can set what your function returns using the return keyword. Key things to keep in mind is to use a colon after your defined variables. You also have to indent the code correctly. And lastly, make sure that if you have default values in the definition of your function, you initialize them after the non-default values. Otherwise, your code will throw an error message and will not run. In the example, the default value is variable 2, which is set equal to 5, which means that unless the user specifies otherwise, it will always default to 5. Before we go on to the examples, let's quickly touch onto package management again. We discussed various options on how to read in specific packages and modules. However, you will need to install them and keep track of what versions you are using. This is where package managers come in useful. They will install packages as well as all the necessary dependencies and make keeping versions up to date very easy. Which one you choose is mostly up to personal preference. Here we listed 3 fairly popular package managers for Python, such as Anaconda, pip, and Homebrew. Installing new packages or updating them is simple and very similar between all of these different package managers. Just use your command line and use the offered prompts. They're all a variation on install package name or update package names. It is very simple. Finally, I will guide you briefly through a Jupyter notebook showing some of the basics we discussed previously. This Jupyter notebook will contain all of the examples shown in the presentation, as well as contain 2 exercises which you can try out yourself. This is what you should see when opening your Jupyter notebook for this webinar. In the first cell, I defined our variable x as equals 2. There's also the definition for a float and a string. Remember that you do not have to specify any types, as Python all assigns this dynamically. As I run the cell, nothing happens. Now, as you remember, you can add floats and integers together. Here we add x and y. I have also written in a print statement to show me the result. Python automatically recognizes that this should be a float. Moving quickly onto lists. Lists, you remember, are ordered and changeable. Here we have a list called list of fruit. It contains apple, orange, and pineapple. We can add or delete stuff from this list. Here we're just adding at the moment. Using the keyword append, we can add the fruit kiwi to the back of the list. Now, if we want to insert a fruit at index 1, which here would be between apple and orange, we use the insert keyword instead. Now again, I have written a print statement to show us the results. If all of this is going right, there should be a pair between apple and orange and a kiwi at the back. You can see the results: apple, pear, orange, pineapple, kiwi. If we want individual parts of this fruit salad, we can use square brackets and a number, let's say 2, to return us an orange. We can also use colons to slice part of this list. Here it returns us everything from index 2 onward. This can come in very useful for some of the later exercises. Now, moving on to dictionaries. Dictionaries are unordered but still changeable. This is the same dictionary that we had in the example. Now you can see that we still got title, author, and year for our 2 books, Great Expectations and The Way of Kings. If I want to query all of the book titles, I can query it through the keyword title as defined above. This should return me a list of the 2 book titles. If I only want one of those, or if I had a longer list, I could return more. But say I only want things at index 1. And this again, it is The Way of Kings. When querying lists of any kind, it is very important to bear in mind that indexing starts at 0 and not at 1. You will run into this problem several times before you start to remember it. Lastly, let's move on to tuples again. We have our furniture tuple here containing chair, sofa, and table. We can query this, but we cannot change it. So we query it like we would query any other string. Here we're saying, well, I would like things at index 2 returned, which is a table. I run the cell, and indeed it returns table to me. However, in this cell below, if I'd say, well, at index 1, I would like to overwrite sofa with armchair, like you would be able to do in a normal list, I can no longer do this. You see, when I run this cell, I get an error message. The error message will automatically point you to what kind of error you're dealing with. Here it is a type error. It will also point you to the line that is causing it, as well as a detailed message. Here, tuple object does not support item assignment, meaning that after we have created our tuple and tried to change it, we cannot do this as it is an unchangeable type. Okay, briefly moving on to functions. This is the same function that we initially looked at in the presentation. Our addition function that takes variable 1 and variable 2. The variable 2 is set to the default value of 5. The result is just variable 1 plus variable 2. Nothing will initially happen when you call this, but if I as a user then call my addition function and give it a variable, in this case 3, and again it will turn 8. Variable 2 you see has automatically defaulted to 5 because that is what a default variable is for. I can however say instead of defaulting to 5, I would like it to add to this number, 1.235. You can see it still works. Now, it is important to add comments to your code, and it's very important to add comments and descriptions to your functions. And the best way you can do this so that it is visible for other users is using this the 3 quotation mark system. This is one way to add instructions and comments to your functions, and they can be displayed when you query that function using help. We'll get to this in a second. Now this new function called makeIntoString can take a variable or function, as functions do, but literally our variable is called variable or function. And what it does is it turns whatever we pass to it into a string and then adds is the answer to the end of it. That full string will then be returned to us. Again, when I originally run the cell that defines the function, nothing will happen. It will only call the function in the cell below. Here, makeIntoString gets past our addition function with the value 4. Now, the addition function will run first, adding 4 to 5, which would return as 9, which would then get turned into a string, so 9 should be the answer. There it is. 9 is the answer. All is a string. Now, as I said, your instructions for a function can be created by the user using help. Here you can see this in the cell below, where I used the help function and typed in the name of the function that I want help with. When I now run this cell, you can see that makeIntoString variable or function, and it returns us the text that I had previously entered when I defined this function. This can store a lot of information such as what variable types should be used or what shortcomings your function may have. It's always worth to have a look at them if you're feeling stuck with your code. The last thing in this Jupyter notebook are a couple of quick Python exercises just to get you going. This is it from this webinar. I hope you found this useful and instructive, and hopefully you find Python as easy and enjoyable as I do. Thank you for listening.